Yes. We were talking about inheritance, right? So, I mean, we saw some weird high-level ideas, but then we actually started implementing something. So we wrote the code for a rectangle, and I know last time we wrote the code for the square, but I'll backtrack a bit. If we're going to look at the rectangle code, here's the header. All we had was a length and a width, the constructors, deconstructor, which is like empty, but we set it to virtual, and that's going to come up again in a second. And then we have get length, get width, get area, and then a toString. And it's angry about something here. All right. And then when we look at the implementation, well, default constructor length width 0, one that takes a length and a width, we'll just set them. Copy constructor, deconstructor, get length, get width, get area. That's it. Now you might say, why not just store the area as an attribute? Yeah, sure, fine, whatever. I guess though, if we were to ever write a setter, like if we had it so you can change the width, we would have to automatically update the area. Let me show you what I mean. Actually, well, no, I won't show you. But if we had an area attribute instead of doing the calculation whenever we call get area, if we ever modified the width or the length, we would have to make sure that we also modify the area because it's dependent on the length and the width. So if those change, it's going to change the area. All right, and then here was our toString. What did we do? Well, we returned this fancy string. Rectangle with the length equal to whatever the length is, and the width equal to whatever the width is. That's it. And obviously, this is a ridiculously simple class. Nothing wrong with it, but it's very simple. We didn't have any generics or templates or anything, but we want to make a square because a square is a rectangle. All squares are rectangles, but not all rectangles are squares, right? A square is a very special type of rectangle. And a rectangle is a generalization of a square. So we're going to make a square class that inherits from the rectangle class because a square is going to have a lot in common with a rectangle, but a couple of unique things. So what we'll do is we'll make the idea, except we won't have a length and a width, we'll have a side. And yeah, so here's what we're going to write. In our header, I'll just go here. Square header, what do we have? Well, we included the rectangle header, and then we're saying class square, but then we've got this colon public rectangle, and that's saying, okay, yeah, inherit from the rectangle class. And you remember, so we didn't actually include any attributes, but here I have an isUnit attribute. That's going to be oh, is it a unit square? Is it 1 by 1? I don't know. This is silly, but I'm just doing it anyways. Our constructors, our deconstructor, and here we have toString. But if we go back to the rectangle, we'll see, well, we've got the toString here as well. But when we define a function with the same name as something as the parent class, we override it. It means, okay, if you ever have a square object, don't call the rectangles toString, call the squares toString. And we also added another method called getSide that does not exist in the rectangle class. We've got getLength, getWidth, getArea, but no getSide. You will also notice that getLength, getWidth, getArea are not included in here. We didn't write them, but that's because we get them for free when we inherit from the parent class. So let's check out here. So rectangle false. If s equals 1, okay, it's the unit. And here we're saying okay, if there was nothing unique going on, if the isUnit attribute wasn't defined, this would be our constructor. We would say, okay, squares constructor is, we'll just rip off the rectangles. Just don't do anything special. Call the default rectangle constructor. But then I'm adding a couple of extra little things here. Is_unit set to false because a 0 by 0 is not the unit square. And then here we've got one where it takes the side. And well, what does it do? Well, it calls the rectangles constructor that takes the length and the width. But of course, the side is going to be the length and the width for that rectangle because, well, that's what a square is. And then we're checking, well, if s is 1, well, then set its isUnit to true. Now we've got our copy constructor. We just call the rectangles, but we throw in the, if this getLength is 1, unit vector, else it's false. And our deconstructor, there's nothing there. But because because we set the rectangles deconstructor to be virtual, it requires us to write the deconstructor for the child classes. And then what else we have? We get side. All right, return get width. You might say, wait, why get width? Why not get length? It doesn't matter. Flip a coin. They're the same. It's not going to matter. You might also say, why not just call like length, right? Because length is an attribute of this object. Well, here's the thing. It's not actually directly accessible in the child class. In fact, the error down here says member rectangle length declared at line 7 of blah, 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 rectangle.header is inaccessible. It's telling me like, look, I know it exists, but you're not supposed to have access to this. It's a private attribute. So we have to access the parent class's private attributes through the getters and setters, because the getters and setters they're defined in a way that we know that our accessors and getters are working the way that the class they belong to intends. So it's just like a safety precaution. And then our toString. Here we're overriding it. Here it's saying, okay, look, square. I know you inherited from the rectangle class this code. I know you did, and it's for the function toString. But look, ignore that. Here's your toString. So if I ever call toString on you, call the square's toString. So if it's a square, it'll use this one. And again, get length, get width, get area. Although they're not written here, they kind of are. Like, we get them for free. We inherit them for free. But of course, it's going to be mad because of like the length is the private attributes. So yeah, now here we've got our square class, and it's I guess we could add like a get unit. Def, nope. You know what? I'm going to add it for fun. Bool is unit. We'll return true if it is, false if it's not. Nope, that's the rectangles. Bool is unit. Just return is unit. Because is unit is a Boolean, so whatever. Dual bool. Okay, and that should be it. So let's go check out the code. Yeah, Yeah, we did this last time. This is just all the stuff we just looked at. Get side, inherit things. Okay, the square has the length, the width attributes, but we're not actually able to access them directly. And we get the following for free: the get length, get width, get area. ToString. We get the ToString method for free, but we don't like that one. We're going to write one for the square class. This is called overriding. All right, so here's what I'm going to do. I'm going to copy this. This is test code, okay? So, oh, I guess I'm going to have to rs. Include square. All right, now it's not unhappy. So here's what we're going to do. We'll print out rectangle. Then we'll create a pointer to a rectangle with the size 5 and 10. And then say, okay, what's your length? What's your area? What's your string? You know what? Let's get the width too. Why not? Get length, get width. Get your area, and then ToString yourself. Then create a square that is sides 6. And here's what we'll do. I'm also going to call the get width here. So here, get length, get width, and get side should all be returning the same thing, specifically 6 in our case, because 6 is the side length. And then we call the get area. Well, that's inherited from, and then the ToString. So if I were to ask you right now, here's a quick little test. Don't answer it, but answer it in your head. How many of the methods that I'm calling here did I specifically... I gotta be careful not to try to make this a trick question, because I'm not trying to make it a trick question. How many of these methods are directly from... I won't make it a question. Here's the thing. Get side and ToString were the only methods I wrote. I guess I could also call like is unit. the get side, is unit, and toString were the only ones that were actually written in this file, in the square CPP. All the other ones we got for free. The get length, get width, get area. But of course, toString we got for free, but we overwrote it. We wrote the toString to override the parent class's toString because we want a special toString for ourselves. Okay, let's see. Let's make sure I'm not crazy and this all works. Okay, build it. Uh-oh, what did I do wrong here? Non-standard syntax. Huh? This get length. What? Oh, there. That'll fix that. Okay. So, what do we see? Well, why is unit 205? Well, that's weird, but I'll look at that later. So, what do we have? We create the rectangle. Length is 5, width is 10. So length 5, width 10. Area is 50 because 5 times 10 is 50, and that's what area is for a square. And then the toString. Rectangle length is 5, width is 10. Great. Now the square stuff. Length 6, width 6, side 6, area 36. 6 times 6 is 36. Is unit somehow 205? I'll go back and look at this in a second, see if we can find out why it's coming up as 205. And then square is, well, it's just side 6. So let's see, can we find out what's wrong with our is unit? So is unit, it's just set to a Boolean. Do I have to like std to string it maybe? I'll always forget this type of stuff because C++, as I always complain about, I immediately forget once May 1st hits, and then I have to remember it. Nope, still 205. If it's not obvious, whatever, I'll skip it. There's probably just something funny wrong, something going on. So it's set to true. I guess 205 is true because false is 0, and anything that's not 0 is true. But why 205? Is unit set to true? False. No matter what, it's set. Oh. How embarrassing. Oh. There, that may have fixed it. There we go. Is unit is 0. Oh, and I guess, yeah, 205 is true. Wouldn't have made any sense because it's not 1 by 1. Whatever. So there, now it's fixed. For those of you who are left scratching your head going, wait, how did he fix it? If I set, so when I declared is bool, I didn't assign it any value or anything. And in a default constructor, it just automatically sets it to false. And then here, if its side length is specified and the side length is 1, it sets is unit to true. But before, when I didn't have this, it would have left is unit to be just garbage. It would have been not assigned to anything. So I made a huge, silly mistake there. And then here I did it right. I don't know why I didn't before, but whatever. Cool. So look at that. Isn't that cool? Rectangle, square. We got all this for free. Get width, get length, get area. Those are not in here. I did not write those here. I wrote them here. It's cool, right? Now, there's even more interesting things to come about inheritance that you're either going to love or hate. You'll probably love it. So inheritance invisibility. Okay, public. Child class can inherit from them directly and access them, except for the constructors, but we can still access them. What this means is anything that's set to public, I can have direct access to, like the get length, get width. If I set length and width to public, I could have accessed length and width in here, but I'm going to be a good programmer and not do that. But all the public things, the child class has access to for free. But we don't have direct access to the constructors because you will see, obviously the constructors and deconstructor are defined, they're defined here as public, but I can't call them directly. But I can, like, indirectly by, like, just hijacking the constructor. So I can say, okay, well, the squares constructor is just going to hijack the rectangles constructor plus this. That's all. Private child class cannot access these things. And then protected, there's another visibility thing. We're not really going to be using it that much, but we can access anything by any class in the same package, including child classes. So because of all the stuff we're going to be programming in this course, protected and public are effectively the same thing with what you've seen so far, but don't use protected right now. Although I think I might use it in one very special case later in the course, but don't use it right now. All right, inheritance, why? Why do it? Well, it's going to save resources. And you might say, well, okay, fine, it saves resources, but I mean, there's all that extra fancy syntax. Wouldn't it just be easier to just copy and paste the code? And you're not wrong, but if you change the original code, but you might forget to change the code that you copy and pasted, you might be in trouble. And now we've got to like alter things in different places. So we're fragmenting our code. It's not consistent. It's not consolidated. That's just a recipe for disaster, especially as your programs get bigger and bigger and bigger. And here's the funny thing. You can inherit from a class that already exists, that you didn't write. So like, what if you imported like the string class, and then you wanted to make a special string class that's going to inherit from the string class? Well, you don't have direct access to that string code, do you? You can't copy and paste it because it's not yours. You didn't write it. It's somewhere else. Now, the child class, if you're doing this the right way and logically, the child class is a more specific version of the parent class. A square is a rectangle, right? But a rectangle is not necessarily a square, right? This shouldn't be groundbreaking, but it's an important thing because parent classes, given that a square is a rectangle, I can do this. Okay, nothing about this line of code is weird. Square pointer s equals a new square. Its side is 5 by 5. But then I can do this. Rectangle pointer r1 equals s. Now, what is the type of the thing that s points to? This is a chat. This is a question for the chat. This might seem painfully obvious. This is not a trick question. It might seem painfully obvious, but it's important to make sure we have this straight. Square. Everyone type square. And hit enter. Very good. It's a square. S points to a square object. How do I know it's a square object? Well, right here. When I said go create a new... my goodness, I'm so bad at this. I hear more boops. Is that still people saying square? Yes. Oh, look at that. You actually drew... I don't know. That looks like a little rectangle, actually. So, I don't know. So, when we say S, you're a pointer to a square object. There is a... I hate this... okay, I can save this. There. It's a square. S is a pointer to a square. S, it's a pointer. Remember, it's a pointer to a square object. This is the square object that got created. Its size is 5 by 5, right? And then I created a rectangle pointer, R1. That is this. And then it points to that same thing. S is a pointer to a square. The thing that S is pointing to is a square. R1 is a pointer to a rectangle. And the thing that it points to is this square. Because the square is a rectangle. Right? Now what? I can even do this. Create a new square, 6 by 6. A rectangle pointer, R2. Oh my gosh, why is it doing this? There. Because squares are rectangles. Squares are rectangles. So the rectangle pointer can point to a square object, or a rectangle object, but a square object is a rectangle object. A square is both. More precisely, it's a square, but the square, it's also a rectangle. I know this sounds like I'm beating grade 2 geometry into your head, but it's important because when we learn about something called polymorphism in a couple of slides, people get hung up on it because they're looking for a new trick and a new set of rules, but there's no new set of rules. What is S? It's a pointer to a square. What is the thing that it actually points to? It's a square. R1, it's a pointer to a rectangle. What's it actually pointing to? Well, it's pointing to the thing that S points to, which is a square. And R2, it's a pointer to a rectangle, but what is it actually pointing to? Specifically, it's a square object. Do you think I could do something like this, where I say like S square S2 equals a new rectangle? Do you think I could do something like that? No. Why no? And I know it's not a trick question. I know it sounds so silly that you might think it's a trick question. Reverse bad. That's absolutely correct. Reverse is bad. All squares are rectangles. Are all rectangles squares? No. The set of all rectangles includes all squares, but the set of all squares does not include all possible rectangles, right? Again, I know it sounds like I'm beating grade 2 geometry into your head, but just wait. Alex is right, reverse bad. All right, do you think we could make it? Okay, I just did that. So, ooh, look at this animation. This is what I did on the previous thing, right? Remember, S isn't the square, it's a pointer to the square. R1, it's not a rectangle, it's a pointer to a rectangle. And oh wait, this is supposed to say R2, I think. And R2, wait, is it supposed to say R2? Yeah, it is. It's a pointer to a rectangle. And then these are the actual objects that exist somewhere in RAM. I've said it a billion times already, I'm gonna say it again. Don't mix up what you have on the left-hand side and the right-hand side. The left-hand side over here, those are the pointer object, or pointer variables. They're pointers. S is not a square, it's a pointer to a square. R1, it's not a rectangle, it's a pointer to a rectangle, and so on. So object type. The type of the object never changes. Once it's created, it is what it is, right? It's defined when it's created. So here, the object that S points to is a square. It's not going to change. If I were to do this, the thing that R1 points to, it's still a square. It's not going to pretend it's a rectangle. It's still a square. Because this object, it knows, like, I am square. It knows. It always knows that it's a square. All right, polymorphism. This is a big word for a simple idea. The behavior can vary depending on the type of the object. So, yes, here we go. Notably, if I say S toString, which toString is it going to call? Is it going to call the toString written in the square class or the rectangle class? Everyone type it in the chat. Square. Why? Because it's a square. The square is a square. This is the square. 5 by 5. I am square. SQ. So when S is like, hey, toString, S is like following this and being like, give me to stir. And then this goes, okay, here, stir. Right? It's like we're asking the object to do something. We're not asking the pointer. We're like getting the pointer to get us to the object to ask it to do something. Now, when I say R1, this is not a trick question. And if you get this wrong, it's because you're thinking too hard and you're looking for new rules. Don't go looking for new rules. Follow the rules that have been the rules since we started talking about the rules. If I say R1, toString, Where is that toString written? Is it the rectangles or the squares? Everyone type it in the chat. Oh, two mistakes. Two mistakes. It's the square. It's the square. So yeah, Dante, you were correct. But Michael and Gabe, geesh, it's not the rectangle. Crap. Is the thing a square? Yes, yes. Why? Because S is the square. I didn't read above. Sure. I'll give you the benefit of the doubt. It's the square. Because R1, what is it pointing to? Although the pointer is a rectangle, when we follow that pointer, R1, and we say, hey, give me your string, the square's gonna go, well, I'm a square, so I'm gonna call my toString and go, here it is, and give it back. And then R2, same thing. It's going to call the squares. Which toString? Yeah. Now, sometimes though, and this is where things can get weird. Now, let me go back here. Polymorphism is the idea that the behavior can change or can vary depending on the type of the object. The type of the object is this. It's the square. It's this thing. When the computer might not know what's actually going to be run. Because imagine I have something like this. I have some random number between 0 and 100. If the random number is less than 50, R is going to be a rectangle. But if it's greater than or equal to 50, it's going to be a square. I haven't hit run. Before I hit run, can the computer know at any point in time before I hit run? Actually, even after I hit run and I'm online, I'm right here. I am right before this line of code. I haven't run the if statement. Like I hit debug and I put a breakpoint on this line of code. Is it possible to know if R is going to be a square or a rectangle? Wait. Is it possible to know that the thing that R points to, assuming R is a pointer to a rectangle, is it possible to know the type of the thing that R points to beyond knowing that it's going to be either a rectangle or a square? Type it in the chat. And don't play the game of like, well, I guess technically if you knew what the seed was and you knew, none of that. Okay, no, exactly. We won't know. Why? Because, I mean, it's like a stochastic process here. You're rolling the dice. And until we roll the dice and we check this condition, we won't know. Is it a rectangle or a square? If rect pointer R, it's a pointer to a rectangle, so it can point to either a rectangle or a square, but I don't know what it's pointing to until I hit run. And we get there. If the method you're calling exists in the child class, then the child class's version gets called. This is just overriding, okay? So if, like toString, if I said toString here, well, which toString is it going to call? Well, if it's a square, it's going to call the squares. If it's a rectangles, it's going to call the rectangles. But if I was saying like R, get width, right? Because get width was not defined in the square class, right? So that's what this is saying. If the method you're calling does not exist in the subclass, then it calls the parent class's version. Well, yeah, obviously, because we inherited it and it wasn't defined there. So if I call square, hey, give me your width, well, it goes to the parent class because that's where it was defined. This isn't really new information. We talked about this moments ago. Yeah, that's just how inheritance works. We already saw this, yes. Now, you can only call methods though. This is super important. You can only call methods that exist in the highest level in the inheritance hierarchy this way if your pointer is the more general version. That's a fancy way of saying R. That's the top of the hierarchy here, right? Because we only have R's and square, right? If I had a pointer to a square, S that pointed to a square, I can never make S point to a rectangle, right? Because that's like, I can't guarantee although we will look at something shortly, but I can't guarantee that that the rectangle, like if I have a rectangle pointer pointing to something that's a rectangle, that might be a square or might be a rectangle, I can't guarantee that I can say S equals the rectangle because I don't know if that rectangle is actually a square, right? So I can't do that. So, wait, did I hear a boop? Can you have a parent class of a parent? Yes, you can. You can have a parent class of a parent class of a parent class of a parent class of a parent class. I could make a parent class called shape that is above the rectangle. And then the rectangle inherits everything from that parent, and the square will inherit everything from above, from the parent and the grandparent and the great-grandparent and the great-great-great-grandparent and so on and so on and so on. Yes. So, if I don't know, let me go back. And let me get rid of this. There. If I don't know what R is going to be pointing to, do you think it is a safe idea to say R get side? Because remember, get side only was written in the square class, and inheritance only goes one way. So, is this a good idea? Type in the chat. If you put it in an else, I'm not sure what you mean there, but in general, the answer is no. It's not, because I don't know if, I see what you mean. If I put it here, yeah, you're right. If I put it in here, well, yeah, I can guarantee that it's a square now, right? But if I put it here, like I replace the toString with this, that's dangerous because, well, the computer can't, like, we can't guarantee that R is actually pointing to a square. Because if R is pointing to a rectangle and I say get side, it's going to be very angry because that's not a thing. Yeah. Okay, yeah, wait, hold on. Let me clear this out. Got to keep an eye on the time as well. We're in great shape. So, how is C++ to know that R is going to be pointing to a square? Because for all it knows, R is a rectangle pointer. It might be pointing to a rectangle and it might be pointing to a square, but it's not safe to say get side. So you might be saying, what if I am absolutely certain, there's no doubt in my mind that R is going to be pointing to a square object? Because I'm a programmer, I'm God, I'm omnipotent, omnipresent, I know everything about my code. So I know that although R is a pointer to a square, the certain chunk of code, I know, R is a pointer to a rectangle object, but at this chunk of code right here, I can guarantee that R is in fact pointing to a square. What do I do then? Well, here's the situation. R, new square, R, wait. This is what I want, right? This is kind of like what was just brought up where, like, well, if we put it in the if statement. If it was here, we'd be safe. But how can C++ guarantee that? I want to write this. How to ensure safe. Like, how can we guarantee? I mean, look, I know this code is written, there's no if, ands, or buts, but C++ is stupid. And it knows that R is a rect pointer. So it's stupid. So how do we guarantee this? Why is R get side and not R? Because R is a pointer. Right? If R wasn't a pointer and was the rectangle itself, then we could do R dot get side. But because R is a pointer to a rectangle, we use the little arrow. Otherwise, we would have to do like this, asterisk R dot get side. Which of course, this like arrow thing is like the shorthand for doing all that. Yeah. Yeah, okay, cool. I think you forgot the start. Well, that would only like in the definition. This is assuming that the pointer was already created, something like this. So I guess really what I should have had here is this. Rectangle star R. There. Now it exists, but it's not assigned anything. All right, so yeah. Well, we can cast things. So if I have 5 divided by 6, what's the answer to this question? What is 5 divided by 6 in C++? Someone type in the chat. 0. Good. It's 0. Why? Well, because they're integers. And the result is going to be an integer. Res is int. It's going to be an integer. There's no ifs, ands, or buts about it. It's going to be an integer. So even though it's going to be some like decimal, the 0 point, I don't know, we truncate it. They're ditched. There, it's 0. But of course, there's going to be times that you don't want to do integer division. You're going to want to do floating point division. So what you can do is you can say, okay, look. A, just pretend to be a double, okay? Pretend to be a floating point number. And now we're doing a floating point divided by an integer, but that's fine. And it'll now convert it. This whole output will be float now. So whatever 5 divided by 6 is will be, we'll be good. It'll actually give us the decimal now. So this is an example of casting. So we can cast here to another thing in the inheritance hierarchy, but you gotta be really careful of the type, because in our situation, we had this, right? If I said R gets side, it's gonna be mad. But what do we want R to be cast as? Well, we're gonna have to cast R to be a pointer to a square instead. To say, look, I know you're a pointer to a rectangle, but I promise that you're going to be pointing to a square actually, okay? So R, I know you think you're a pointer to a rectangle, just pretend, you're a pointer to a square, okay? And then C++ will be like, okay, all right, you're like, this is like God, this is the hand of God coming down when we're casting it. We're saying like, look, shut up, I know, just be a square, okay? Now, what do you think would happen if R was pointing to a rectangle and we tried to cast it as a square? What do you think would happen in this situation? Do you think good things would happen or bad things would happen? Bad. Let's see. You know what? It's always fun to test, right? Especially when to me, it's always super fun to test when the result could be catastrophic, right? So I'm gonna delete all this. So what are we doing? Rectangle pointer R is a new rectangle. And I'm saying toString. Well, obviously we get the rectangles toString. Now, oh, I heard a boop. It would return either width or length. Well, let's have a look. Now we say, okay, R, shut up. You're not actually a pointer to a rectangle. You're a pointer to a square now. Get side. And then here, now do the toString. All right, so let's build this. Actually, you know what? Let's see what happens if I don't cast and I try to call R get side. First, this is saying class rectangle has no member get side. It knows. Even if this was square. It's angry because all R knows, R doesn't know that the thing on the other end is a square. R only knows that it's a pointer to a rectangle. And it's saying, get side isn't a thing for rectangles, right? So that's why we're saying, shut up, be a square. Okay, so I'm gonna build, and then we're gonna hit run, and let's see what happens. Well, how about that? Get side somehow kind of worked. But that's weird, right? Because, well, R shouldn't be pointing to a square where the square was defined. What's going on? So Felix had an interesting thing. Now, if this is a square, nope. Let's make it 55. So obviously it's happy here because it is in fact a square, right? But if we made it 5 and 50 or 10, oh, not square, rectangle. What, I heard a boop. It would return either way depending on your get side function. Yes, you're right. So why? Well, because it's gonna go and call get side. Where's get side, right? But that just calls get length, which is safe. But I wonder what happens if I have like, what happens if I'm not calling something I inherited from the superclass? What if I'm calling something like is unit? Okay, so let's go back here and do is unit and see if this throws it off, because get side, okay, look, the code can go, okay, well, I'm gonna call this function, which all it does is just call this function, which is safe because get length is in the parent class. But what happens when is unit is an attribute of the child class that the parent class doesn't have? So let's build. $253. Well, now we're in that funny situation of it's returning garbage because is unit isn't a thing. This is very unsafe to do. 253, that's meaningless because, right? In fact, here, look, I'll make it 1 and 1. So it should be a unit if it was a square. And let's see what happens now. Oop, it's gonna be mad. Here, yeah, close. Let's rebuild. Oh, it's up to date, okay. Look, it should be true. I mean, I guess it technically is, but this is just a consequence. It's like 253, it's nonsense, that's garbage. So we only got super lucky before with it working. Other languages won't let you do this. C++ is a little bit more trusting of you when perhaps it shouldn't be. You can though. There is a special function that can determine if a type is, the type of things are the same. So if I say type ID, dereference pointer to maybe a square, to type ID of a pointer to a square, this, if this statement is true, then look, I can in fact guarantee that pointer to maybe a square is pointing to a square. So this is an if statement where we can ask type ID of an object, or I guess here, where we have to dereference the pointers. So we call type ID on an object and it'll tell us what it is. And if it is actually a square, then okay, fine, we can do it and we are guaranteed to be safe. We won't have the situation of like the is unit. Hierarchy, yeah. This was Cole's question earlier where it was just like you can have a parent, you can have a grandparent, you can have great-grandparent, and so on. Any questions about inheritance? Now, I will say that we will do a little itty bitty bit of inheritance in the remainder of the class, but inheritance isn't a huge, important, giant thing to take away from this class. It's interesting, it is important, it's something that you're gonna need to know, it's something that you're gonna use in the future. We're only gonna use it in a specific case in this class when we're talking about lists and certain types of lists. So yeah, there's that. Any questions before I say goodbye for the weekend, unless you are the lucky ones to have lab with me? Why would we type ID if we can already make something we know points to a square? Well, in case we wanted to do polymorphism, in case we had something like this, right? I want to be able to randomly check something. And then I can say, well, is unit, but then guarantee that I can cast this as a square with that like if statement. Can't see what you're doing. Ugh, always do this. If we're doing something like this, right, where I don't know until runtime what R is, right? So if down here, like if right here, I wanted to insert the code that we saw here, right? Cast it as a square, but I'm left going, but here's the thing, I don't really know if it's pointing to a square or not. That's where we would check the type ID and then we can put like the condition there. That's all. And you might say, but yeah, but why not just put it up here? And you're right, but maybe the way we've written our code, maybe it's like 1,000 lines of code later where I need to ask this question. It just gives us the flexibility. Hopefully that answered your question. Any other questions? Okay, in that case, have a great weekend, or I'll see you in lab later today. Goodbye. Have a good week. You too.